Welcome to a new test and teardown video. This time it's a power supply from HP. And this one is a model 711, 711A. This is a high voltage power supply, so it is definitely not for a random kid. Look at that, 0 to 500 volts. And 100 milliamps. They added a few cool features in this power supply. We got two individual 6.3 volt filament outputs. They are AC outputs. You can series or parallel them after your needs. However, there is a little bit of something you definitely need to know if you want to parallel these. There will be, of course, a phase thing. And if you want to do that, you need to do it this way. Now you parallel them and you'll get double the current, obviously. The reason why they did it this way is because most likely you want to make them in parallel, in series, and you want to make 12 volts. So that way you just short circuit these two, and then you got your 12 volts here. But I think they could have put in some markings or something here. This is a little bit stupid. They didn't explain this on the front panel. So this is the DC voltage output, and I actually think we should have had a high voltage or a little bit of a warning or something like that, because this is actually 500 volts available on these. If you crank up the voltage to the maximum, you have an on-off for the output, and then there will be a lamp that shows you got output between these two. So look at the meters. There's another really cool feature here about the volts. What if you want to use this power supply for something as low as 50 volts or 30 volts or 20 volts, whatever lower than 50? So of course you need to dial the voltage down to just down here, right? Of course this is a 500 volt scale, so 50 or 40 will be impossible to see. All you have to do is push and hold this in, and then you have 50 volts full scale. And now it's easy to see what you're doing. But of course, don't push this one when you got 500 volts, okay? So and the same apply to the amp meter. So this is 100 milliamps full range. But what if you're only using less than 10 milliamps? So we're down here and it's impossible to read what you're doing. Then you just push and hold the 10 milliamp full scale. This button not only upscale the milliamps, but it also changes the maximum current overload and fallback shutdown system there is inside this unit. So now it will be a little bit over 10 milliamps if you hold this, and then if you're using more than that. And that is of course if you are running like 50 milliamps and you push this button, and then it's gonna say clickety clack, and then it's all gone. You need to recycle power as far as I've been reading. So, output voltage. Now there's another cool feature in this unit. So, can you hear this? And that was the first. And that's the next one. So, of course, this is 500 volts, linear regulated with tubes. This is an all tube power supply. And of course, you don't want to overheat your tubes with a lot of voltage across them. So this is actually two switches that connects a tapping of the transformator to a voltage doubler. And this way, minimizing the power loss. So you should expect a quite high efficiency if you could talk about a tube product with high efficiency, but this is mainly what it is. And this is a very common feature of even modern power supplies, even something as modern as this. If you dial up the voltage, you will hear the clickety-click relays and stuff. But here it's just done with mechanical contacts that is directly on this switch on the shaft, right? So, well, why don't we just power it up and see if it blows a fuse? And I believe we're ready to power it up. Fuse is okay. We don't have any direct connection from mains to chassis. And chassis is now grounded. So I should be safe. I dialed down everything. This is off. This is off. Oh, let's power up. Mains input is now on. And 50 watts, 30 watts. So I'm getting nervous on my old days. I think this is due to the last few days experiments, because I did kind of take the fuses and stuff a few times. I see some volts here and we don't have it. Ooh, the pot here is cranky. Oy. Ha! So this thing can't go less than 23. But we need to see this warmed up before we do anything. Let's try and push this. Yeah, 20. How cool is that? So that works as well. So that is 18. Yeah. And it's still going down. That is exactly. Well, how about the fine? Okay, are we ready to crank up the juice? So that was 100. Let's see. We're still in the warm-up. I can see it is drifting quite a lot. Ooh, I can feel I'm now almost at the point where the switch is activating, and that is exactly what I want to see. I want to see there is a smooth output between this. Let's do that. It should come now. Yeah, click. And nothing bad happened. I went through this switch and it was all smooth. There's another one here. Yes, I can feel it now. And now. So we got 400. No bad sounds, no nasty. Oy. 500. Okay, and this is my... It was not supposed to give more than 500. But it looks like it can give 600. So if we add 500 here, so there's an additional 50 at least here. So now this all the way down, and this is 500. Yeah, you see? So it's almost 600. So there's a little bit of a margin, but obviously this is this is not loaded. So how are we going to load this? That is something I will sit and meditate a little bit about. So what happens if I... Ooh, and it goes fast to 0. That is great. I kind of like that. So let's pull these out and let's see the 6.3 amps. Ooh, we have to go to volts AC. Oh yeah. And that is of course unloaded. And see, here's the fun thing. Oh, there's a very little capacity between those, so that is absolutely fantastic. So what if so we can make a little demonstration here. So if I take the two top ones, and then I take another cable and short circuit the two at the bottom, then I get my 12. Okay, so this proves the direction of the phases. What if I do it this way? From that one to that one. And then I get 0, because now these two goes up and down in the exact phase. Isn't that cute? The other way it was opposite phase, and that doubles the voltage. So that is very important, and I must say I'm a little bit angry about they didn't put markings on the front plate for that. Very, very important. Also, there's another thing about the ground. You're supposed to, okay, let me take it down to 100. Okay, so it's not going to kill anybody. So here is the DC voltage. I put my output again, and I crank it on, and we go, okay, 93, whatever. So let's try and measure to this chassis. So this is chassis, this is earth, this is ground, and obviously this is 10 mega ohms. So now you're supposed to be able to connect either the negative or the positive output directly to chassis, depending on if you want to have a positive or a negative high voltage supply. So that is one of the important features about this power supply. However, I'm not going to do this before I've measured the current capability of this problem to my chassis. So I'll do this with a resistor. So here is a 10K resistor, and now I'm measuring the 75. Okay, let me do this again. Remember, I had almost 100 between the output, right? Let me show you guys this. My positive and my chassis is 164. This is because chassis is negative, even further below my ground. It's 93 down. Okay, so you get the point. So between, now I'll try and do this a little bit more visual. Let me take these two again. So here is a 10K resistor, right? Look what happens. Ooh, ooh, ooh. So I kill the output, and this is because there is a leak. There is a problem. There's something in here that is connected to chassis that is not supposed to be connected to chassis, and I'm going to find that problem. So that is what we need to do, and we need to open it and fix it. So now I am inside. A little bit dusty. I just touched the top of the capacitors here and this thing fell down. So what the heck is that? They're trying to trick people to think, ooh, they're so big, those capacitors. That is exactly like cornflakes. Maybe I could... Anyway, so where is the leak? We got something here that is connected directly to chassis, so that is interesting. What else have we got here? Instruments? Nah, I don't think so. Here we got the overload relay. They put it in a little cute tube socket relay. Let's have a look if we can. Yeah. That is the cutest Yeah, okay, that is easy to put down again, like that. I believe that will be the different current sense, probably something with that, right? And the bottom side, so that capacitor, its chassis is mounted to chassis here, right? But again, I see both. Ooh, look at that. This is an output. That is interesting. By the way, I did check everything here is discharged, so I can poke my finger around. Just don't you worry. So that will be all the selenium rectifier for all the bias supplies and all the small stuff driving all the small tubes. That will be the voltage doubler. And what we see here is the voltage knob. See? And it clicks that relay. And then if I continue, clicks that one. So that's the different transformator windings. And then of course they go to that one, goes to the capacitor. Oh, and that is the other side of the rectifier. So that will be the two nasty. But I don't think that is the problem, because they are completely isolated, so they can't leak. I expect that one to be the leaky thing. So how are we going to... I am going to do a little bit of experiment here. This was an obvious candidate, C5. This is a capacitor that is directly across the output, and this is of course a metal thing. So I tried to loosen the screw that is holding it, so it was just hanging like this in its plastic. So that means definitely it is not mounted or connected to the chassis, but I have the same leak still. So where the heck can it be then? Now I am a little bit stuck. I don't know if I need to show you all the funny experiments I do here. It's going to take all night long. Well, first of all, it was not C5. Fantastic. So what the heck can it else be, you know? Selenium rectifiers, they are mounted to the chassis with a bolt. And it looks like it's isolated and everything is super duper fine, right? But how can we know for sure? So I started with the two easiest, just to unscrew everything and just hang them in some tape and stuff. And it's still not that. So I still got this annoying leak that won't allow me to connect either of the outputs to chassis. And that is exactly what you need to be able to do. That is an important safety feature. You must be able to do that. So I will not have it any other way. But where the hell is this damn leak? And it's now I'm about to be a little bit sick and tired of this. See what I just did? I unscrewed the mains transformator and I just put the whole unit on top of some plastic. So that means, seriously, if there was a leak in that one, I will be able to figure it out, right? But it's just the same problem. So what have we got left? The only three things left. That will be those three selenium rectifiers. There's nothing else that can be in anywhere near metal here. So where the heck is it? Is it one of these three? What are we gonna think? And are they this type that when I remove the screw they're just gonna go into pieces? I don't know. I've removed the three screws from the three small selenium rectifiers and just lifted them up as much as I can. See, they don't touch any metal, and I still have the problem. And I'm now running out of options. I tried everything. And this capacitor too. So what else can it be? There's nothing left that can have like a leak to metal. And the transformator was also lifted. So where the heck is it? Can it be inside the potmeters? Can they leak? I have no idea. So now I'm probing the voltage on C2 and C3. That is after the voltage Doppler, and let's play with the volt setting and see what happens. See, this is 400 volts. So when I dial up the voltage here, see what happens here is this first switch is going to be activated. Boing. And then we go from 400 to 550. And then we go up to 700. So that is to give you the 200 volts you need for this series regulator to work. So I think it is a little bit over driven at the low part of it. See, we start with 400 volts, and that is already from zero output, right? So, and all the way up to 150 volts output, we got 400 volts on the input capacitors. So that is a little bit on the high side. You are not going to believe what I just tried. See? That will be the 4 potmeters. Those are for the set of the 0. This is the fine, and this is the voltage adjustments. They are very important. They are isolated from the chassis. See what I did? I removed all connections to all of the potmeters. Those 2 red wires here, they go to that one. So now there's only one wire from this pot to that one. One resistor to that one. One resistor from that one to that one. And nothing else. So that means no matter what I do, if I measure from any of those pins to chassis, I should measure absolutely nothing. But that is not the case. From this pin, I got 86 kilo ohms to chassis. Ha ha! So the problem, that is one of those 4 potmeters. But which one? You're not going to believe it. Let's try and show you guys. So this is the chassis, and here we go and look a little bit closer on this potmeter. Now, as you can see, I've removed all wires and connections to this potmeter. But let's see. Oh, my hands is a little bit in the way. Look at that one. 179 ohms to the center tap of the pot to chassis. So this potmeter is clearly leaking, and nothing else up here is leaking. So I found the problem. Now I can go and fix it. I'm so happy that I found it, and it was the last thing to expect. What do you know? So this is R31, the trimmer potmeter that I talked about. Look what I did. I opened it, and there are like funny hairs that is growing on the wiper. And look, this one in here, this is metal that is moving, and this metal that is moving, and those funny hairs, metal hair, go all the way down to the electrical wiper that touches the resistive track. So this is where the short circuit is. And this is what's causing all the problems in this unit. So this is a 50K, and what I did is I measured the position of the pot to 22K. So when I put in a new one, I can just pre-adjust it for the right setting. So hopefully it's going to be a success. What I think I need to do is actually buy 2 of them, because they're both 50K and they're both the same place in the system. They are also more or less the same plus minus voltage over the chassis and all that. So there's probably the same problem in the other one. However, I don't measure anything with my ohm meter, but this is not the same as it's not going to happen next year. So I think I want to fix this so it's going to be a more permanent solution.